Dear friends, welcome to the content on polynomials. In this content, we will learn the different terminologies used in polynomials like constants, variables, and degree of polynomial. Then, polynomials in one variable, remainder theorem, factorization of polynomials, and algebraic identities. Algebraic identities. These are the algebraic elements used to represent polynomials. Constants are the static values. Static means their values do not change. Any numeric value is static value, as it does not need any further substitution to evaluate it. All numbers are constants. A variable is a character which is unknown, unspecified, or arbitrary. It needs to be substituted by a numeric value in order to evaluate it. A, B, C, X, Y, Z are all variables. When we combine variables and constants using mathematical operators like addition, subtraction, multiplication, and division, we get an algebraic expression. Polynomials. Now that we know what is an algebraic expression, let's define a polynomial. A polynomial in X is an expression of the form a n x raised to n plus a to the base n minus 1 x raised to n minus 1 plus a to the base n minus 2 into plus a to the base n minus 2 x raised to n minus 2 plus a base 0, where n is a whole number and a0, a1, a2 till an are real numbers. In this expression, an x raised to n a to the base n minus 1 x raised to n minus 1 till a 0 are terms of the polynomial. ai, that is I is equal to 0, 1, 2 till n are coefficients of x raised to I. X raised to n is the highest power of the polynomial. An x raised to n is the leading term of the polynomial. An is the leading coefficient of the polynomial. Degree of a polynomial. Before we define degree, we need to understand how to represent the polynomial in its correct form. When we write the terms in descending power of the variable, it is said to be written in standard form. The coefficient of every variable is the constant multiplied to that variable. A polynomial consisting of only constant is called a constant polynomial. It always evaluates to the same value. If the constant polynomial evaluates to 0, it is called a zero polynomial. Whenever variables are present in the polynomial, the highest power of a variable among all the terms is called the degree of the polynomial. Since zero polynomial does not have a variable and is not a power, it has no degree. Degree is not dependent on the number of terms in the polynomial. The terminology used for classifying polynomials based on number of terms is monomial, binomial, and trinomial, where monomials are polynomials with one term, binomials are polynomials with two terms, and trinomials are polynomials with three terms. Polynomials in one variable. If an algebraic entity uses only one variable in polynomial, it is said to be a polynomial in one variable. Examples: 5x minus 7, 9y minus 4. Here, although 5x minus 7 is a binomial, it has only one variable x. Similarly, 9y minus 4 has two terms but only one is variable. Hence, these are polynomials in one variable. Similarly, there are polynomials which have more variables is given in this example. Note that the fourth polynomial has four terms but has only one variable with different powers. Hence, it is still a polynomial in one variable. We will study this type of polynomials in detail in this chapter. Linear, quadratic, and cubic polynomials. Polynomials of degree 1 are called linear polynomials as their highest order is 1. Their general form is ax plus b. Similarly, a quadratic polynomial has degree 2 and its general form is ax square plus bx plus cx. A cubic polynomial has degree 3 and its general form is ax cube plus bx square plus cx plus d. In all three of these types, a, b, c, d are all real numbers and a is necessarily a non-zero number. This is because if we multiply any variable with 0, it will be removed from the polynomial. For example, a cubic polynomial with leading coefficient 0 would no longer be cubic polynomial and contradict the definition of cubic polynomial. For this reason, it is necessary to take care that leading coefficient, that is a, is always non-zero. Zeros of a polynomial. The values of x which make the value of polynomial px 0 are called zeros of the polynomial px. Zeros of the polynomial px are also called roots of the equation px is equal to 0. Some polynomials do not have any 0 because there is no value x which makes the polynomial value 0. Constant polynomials do not have any 0. In the following example, note that the number 0 is not the 0 of the polynomial. However, it can be a 0 of some other polynomials. The polynomial can have no 0 or more than one 0. The number of zeros of a polynomial is less than or equal to the degree of the polynomial. Remainder theorem. Remainder theorem for polynomials follows the same rule as normal numeric calculations, which is dividend is equal to divisor into quotient plus remainder. For example, if we divide the polynomial 3x raised to 4 minus 4x cube minus 3x minus 1 by x minus 1, then dividend is 3x raised to 4 minus 4x cube minus 3x minus 1. Divisor is equal to x minus 1. Quotient is 3x cube minus x square minus x minus 4. And remainder is minus 5. Let px be any polynomial with degree greater than or equal to 1 and a be a real number. If px is divisible by the linear polynomial x minus a, then the polynomial is pa. Factorization of polynomials. To factorize a polynomial, we need to consider following two conditions. If px is a polynomial of degree n greater than or equal to 1 and a is a real number, then 1. X minus a is a factor of px if pa is equal to 0, or number 2, pa is equal to 0 if x minus a is a factor of px. This means both the conditions imply each other. Keeping this in mind, we can factorize this polynomial. We have 6x square plus 17x plus 5, which is a quadratic polynomial. Hence, we multiply the first and third coefficients, which are 6 and 5. This gives 30. Now we split the middle term 17 in such a way that the product becomes 30 and sum becomes 17. The solution we have is 15 and 2. Now we split the middle term as 15x plus 2x. By taking out the common terms, we get 3x common in first two terms and 1 in next two terms. Now again we take out the common term 2x plus 5 and we get the two factors as 3x plus 1 and 2x plus 5. Algebraic identities. Here are some of the basic identities which can be used in various polynomial calculations. These identities cover the basic formula like square of the sum and difference, difference of squares, cube of sum and difference of cubes, and also some identities like fourth one, which tells us how to find middle term and the last term of the quadratic polynomial whose factors are given. Examples. Now that we have seen the algebraic identities, let's see how to use them in following numerical problems. First, let's multiply 105 and 106. We know that these are big numbers, but they are closer to a round figure of 100, which can make calculations easier. Hence, we split the numbers into 100 plus 5 and 100 plus 6. Now we see that this expression is of the form x plus a, x plus b, where x is 100, a is 5 and b is 6. The identity says that the first term is square of x, middle term is sum of a and b multiplied to x, and the last term is the product of a and b. We substitute the values at the corresponding places and get the result fairly easily. Similarly, we try to evaluate 99 square without actually multiplying 99 with 99. We can write 99 as 100 minus 1. Hence we get the expression which is in the form of square of difference. In this case, the first term is square of 100, second term is negative, and it is twice the product of 100 and 1, and the third term is square of 1. Substituting these values, we get the square of 99 by just using simple addition and subtraction. Test yourself. These are a few questions for you. Please revise the concept by solving them on your own. Thank you. This content was developed under Akash School project. This project is funded by NME ICT and MHRD, Government of India. If you wish to contact us, please mail us at the given email ID. Thank you for watching this content.